fractional exponents. So here's part 2 of section 1. Fractional exponents are when your exponents are fractions. Makes sense, right? When your exponents are exponents, when your exponents are fractions. So when your exponent is fractions, so a raised to the 1/3, that would be a fractional exponent. Okay, 8 raised to the 2/3. That is a fractional exponent. Remember, getting a good practice of trying to not be sloppy, kind of like my handwriting. Don't be sloppy like my handwriting. But make sure they're on a different level. Okay, your exponents are on a different level than your base. Kind of like when you're taught in elementary school. You got that line, and you do your lowercase a's and then your uppercase a's. Same thing kind of with like exponents. Make sure, like if I have 8, and then it would be raised to the 2/3. So see how they're different? They're on different planes here. So they're on different levels. So make sure you get good at that, so it's not confused that it's 8 times 2/3, because it's 8 raised to the 2/3, which means something totally different. So these are also called rational, kind of like rational numbers, rational exponents. So if you remember what exponents means, like 3 squared means 3 times itself 2 times, which is 9. So 3 squared is 9, right? So when I kind of go the other way, so when exponents mean multiply by itself so many times. Okay, so when I go backwards and when I do a rational exponent or a fractional exponent, so if I do 9 to the 1/2, I'm going backwards and kind of in this order. So this way I said 3 times itself two times is 9. This one, when I go backwards, I'm going to say what times itself self 2 times is 9, right? So this way is saying, okay, go ahead and take your base. This way is saying, go ahead and take your base and multiply by itself this many times. This one is saying, okay, what times itself 2 times is 9, okay? Erase that. So what times itself 2 times is 9? Well, that answer would be 3. So that means this answer is 3. So that's what fractional exponents are asking. It's asking what is being times by itself. So this way you are finding the base. So whenever you have a fractional exponent, it's asking you to find the base. So it's asking you to find what is the base that you would normally square or times by itself 3 times or anything like that. It's asking you to find what is the base. The denominator of our exponent, okay, that fractional exponent, the denominator is saying how many times you're multiplying a number by itself. So the denominator saying how many times. Okay, so that's what the denominator tells you. So that's and it kind of looks, it's this form, right? So it's asking for what is the base. That's kind of the generic form of it. So let's get into some few examples. So again, this is just a continuation of, so here you can highlight problem 4 and you can just highlight whatever the answer is here. But we're continuing on section 1. Okay, so simplifying the expression is asking us to find out, this is asking what is the base. So the denominator tells us the power. Okay, so this is asking what times itself 4 times is 81. Okay, so it's not 81 divided by 4. It's what times itself 4 times is 81. Okay, and so what you can do is one way to do is just start with, we know 1 times itself 4 times is still 1. We could do 2, so we could just get on a calculator and start doing this. 16. 3 times 3, that's 9, times another 3, that's 27, times another 3, well, that is 81. So what did I multiply by itself 4 times? How many 3's do I have here? 1, 2, 3, 4. So I multiplied a number by itself 4 times, and that number that's being multiplied by itself 4 times is 3. So 3 to the 4th is 81, so our answer to this is 3. Oops. So we're going to go ahead and highlight that answer. Answer is 3. So it's a little bit different, but it's asking what times itself, the denominator amount of times, is that base, okay, is the base of the fractional exponent. Okay, let's go ahead and do a quick one of these. So this is asking what times itself, how many times? 4 times is 16. So what times itself so many times is this base of the 1/4. So what times itself 4 times is 16. Well, if you took those answers from before, you know how we went 1 times 1 times 1 4 times, and we went 2 times 2 times 2 times 2. That was 16. So our answer is 2. Okay? Because 2 times itself 4 times is 16. So another way you can do it is like this. Put a box here as your answer, and you can just ask yourself, what times itself 4 times is 16? So what times itself this many times is 16. Okay, now we're adding some expressions. Again, we talked about expressions in class as just being simplifying. Might have a letter in there, might just have a number, but it's just no equal sign, right? So it's really the same thing as kind of before. But now notice that this one has a numerator, okay? So the denominator still asks. So the denominator is still 2. And it's saying how many times we're multiplying a number. So what times itself 2 times is 64. Okay. Okay, so that answer, we're only doing 2 times, so that's a little easier to do, right? And we might know this answer, right? Because it's backwards from exponents. So we know 2 squared, or 8 squared, is 64. So that means 64, not 16. 64. So if we go backwards, 64 minus 16 to the 1/2 is 8. So this answer is 8. But now we have this numerator. Well, this numerator stays a power. Stays a power or stays an exponent. So it's going to stay as an exponent on our answer here. So now we take 8 to the 3rd. So now we're going to take 8 times 8 times 8. Okay, so that answer is 512. Okay, so you can go ahead and try this one on your own. So the denominator says what times itself twice is 25, and then raise that to the 3rd power, and that's going to be your final answer. Okay. All right, so here's 6, so a little more complicated. Again, expressions, adding some letters in there. Remember, this is all multiplication, so we can rearrange this however we want. We can put all the coefficients together. Remember, there's a 1 here, so if we want to list it, we can, but we don't have to. Okay. And then we have this 5. So put all the coefficients together. You can multiply those. 2 times 3 times 5, that's 30. Okay, and then we can put all our a's together. Now this might seem really complicated, but it's just like yesterday, or the first part of this video. And put my b's together. Again, it's all multiplication, and we multiply by the same base. What do we do to the exponents? We add them, right? So here we're just adding fractions. These two are pretty easy because they already have common denominators. So 2/3 plus 1/3. 2 plus 1 is 3. Keep that denominator the same. All right, and 3 over 3, that's 1. 3 divided by 3 is 1, so we just get 30a. Now my b's, they're a little more complicated because when I add those, I have to take a quarter plus a half. So I need a common denominator, so I have to go ahead and multiply top and bottom of this fraction by 2. So then when I multiply that, I get 1/4 plus 2 over 4. So I just change this to 2 over 4. Now I can go ahead and add, right? So I get 1 plus 2 is 3, so I get 3/4. So this is b to the 3/4. So at least what you can do is multiply your coefficients, all right? So you can pause this and try it yourself. But multiply your coefficients, right? And then put your variables together. And since we're multiplying, that means we're going to be adding. Well, this one's a little easier because, again, it has common denominators, right? You need to make sure we have common denominators. Say I don't know how to add this. What you can at least do, at least get this far, is I already did my coefficients and put c. I know since these have the same base, c, that I'm going to be adding these fractions, right? So at least get that far where you can put 4c to the 3/5 plus 1/5. If you don't know how to add fractions, at least get this far where you put those exponents, you're adding them, right? Then if you know how, go ahead and make sure you have a common denominator 5, so we can go ahead and add the top. And there's your answer.